Welcome to a lesson on measurement errors, absolute error, accuracy, precision, all that stuff. Okay, so let's start off. Key idea number one. The first thing you need to understand. This whole topic is based on a premise. This whole topic is based on the idea that all measurements are approximate. Every measurement, like, if you weigh yourself or if you use a ruler, anything at all, every measurement is an approximation. All measurements are approximates. Now, the error can come from the equipment being used or the person using the measuring device. So maybe it's a human error, or perhaps it's an error of the equipment being used. For example, if you use this ruler only contains centimeters and millimeters. You couldn't measure more accurately than to the nearest millimeter. It's not physically possible because this measuring device, this ruler on the screen, right, it's only got millimeters. So that's the most accurate you could measure with this ruler. And that's why every measurement with this ruler would be an approximation to the nearest millimeter. Hopefully that makes sense. So moving on, key idea number two. All measurements are approximate because they've been rounded off. Something which has been measured to be 5 centimeters could in reality be anywhere from 4.5 to 5.5. Sorry, that's a mistake on my part. It should have been 4.5 up to 5.5. And you can see, if you look at this device, look at this red line that I've drawn. Now, it looks like it's roughly 5 centimeters, but I guess the question you need to ask yourself is, does the red line go perfectly to 5? Does the red line start perfectly at 0? And that's why it's an approximation. They've been rounded off. So if you look over here, if you zoom in, I don't think that starts at 0. And I don't think it's perfectly aligned with the 5. So obviously in this case, it's a lot closer to 5. But the idea is that red line could be anywhere from 4.5 to 5.5. Anywhere in that range. And then if we use this ruler, because this ruler only measures to the nearest centimeter, we would say it's around 5 centimeters, because you can only measure to the nearest centimeter on this ruler. Now, if you might say, what if I measure very accurately and use ruler which has millimeters? Well, then look over here. Look at the second example. We say this is going to be around 5.1, right? 5.1 centimeters. And hopefully you can see, we would say that is around 5.1 centimeters, because it goes up to 5 and then it goes a bit more than that, so we could say roughly 5.1. Now once again, my question is, does it start perfectly at 0 and does it end perfectly at 5.1? Now we can zoom in, I guess, and as you can see, I don't think it ends perfectly at 5.1. As you can see, it has been rounded off to 5.1. And does it start at 0? It doesn't start at 0, look. And so, hopefully you're getting the idea that all measurements are rounded off. All measurements rounded off, and that's why all measurements are approximations. Okay, this is the premise of the topic. This is what the whole topic is based on. Now we're going to move forward and we're going to look at how can you determine, the range of values. So if someone tells you I'm 87 kilos or I am 154 centimeters tall, then how can you determine how accurate is that measurement? Mathematically speaking, how accurate, how precise and how accurate are those statements? So let's have a look and let's move forward to the mathematical sides of things. So how accurate is a measuring device? And the smallest unit on a measuring instrument is called the precision of the instrument. Now, you know what, I'm going to change this, this word, because accuracy and precision are actually slightly different words, so I don't want to mislead you. So if the question is how precise is a measuring device, then the answer is the smallest unit on a measuring instrument is called the precision of that instrument. So this is a ruler. The precision of this ruler is 1 centimeter. because what's the smallest measuring unit? What is the smallest unit? Smallest unit on this ruler is 1 centimeter. Okay, 1 centimeter is the smallest unit here. Now, if you go over here, the smallest unit on this ruler is 1 millimeter. The distance from there to there, that is 1 millimeter. And so the precision of this ruler is the smallest unit on that ruler, which is 1 millimeter. And then you could have, I know this is not very common, but you could have a ruler which has centimeters, and then it's got half of a centimeter labeled. And so how precise is this ruler? Well, the smallest unit on this ruler is 0.5 centimeters. From here to here, it is 0.5 centimeters, or half a centimeter. And that's why the precision of that unit is half a centimeter. So precision is the smallest unit on a measuring device. Now keep this in mind, remember this, because we are going to use this, okay? It's part of some things we're going to do next. So, moving on. Key idea number 4. So the absolute error is equal to plus or minus half the precision. Okay? So just a reminder, precision is the smallest unit on a measuring instrument. So you need to know what precision is. The smallest unit. And if you half that unit, you get absolute error. Plus or minus of half of the precision is absolute error. So you get the precision, you get the smallest unit, you half it, and you make it plus or minus, and that's absolute error. Okay, so let's do an example or so. Yes. So this absolute error will help us determine the range of values which a measurement could have been rounded up or down from. So let's have a look at some questions. So if you had a measurement of 18 centimeters, what is the precision? What is the smallest unit of this measurement? The smallest unit that is measured. Now it has something to do with place value. This is ones. That is ones. That is tens, right? This is tenths. And so the smallest unit over here is going to be the ones. So it's going to be 1 centimeter. And the smallest value over here, we're just going to make it 1. So the smallest is tenths, 0.1. It's going to be 0.1 kg. That's going to be the smallest unit of measurement. And absolute error is half of the precision. And so we half the 1 centimeter, it's going to be 0.5 centimeter, and we put a plus or minus. Half of this, and you're more than welcome to use a calculator. So let me just pull out a calculator. If you're not sure, don't risk it. Don't have to do it mentally. 0.1 divided by 2. That's 0.05. So 0.05, and you just put a plus or minus. Okay? So that's part 1, and that's part 2. And that's, okay, you get the idea. That's for B, and that's for A. Okay? And so, precision, smallest unit on a measuring device. And in terms of, if you already have a measured value, then you just look at the last place value given. So if for example, you were given 5.232 or something, then the precision, you'd look at this number, and you'd make this 0, you'd make that 1. So 0.01. And I don't know, let's say that's grams, I don't know, whatever. So that's how you determine precision. Okay, you look at the last number, and you make that a 1, and everything else becomes a 0, more or less, and that's how you get the precision. You half this to get the absolute error, and you put a plus or minus at the front of it. And this tells you that it was rounded up or down by half a centimeter. This 18 centimeters, this value could have been plus or minus half of 18. So 17.5 to 18.5, anywhere there, and that's the range value. And we're getting that in a second. That's called the limits of accuracy. So key idea number 5, limits of accuracy. It's the range of values which could have been rounded off to give a certain measurement. And to do this, you get the actual measurement. So 18 centimeters over here, 18 centimeters or 2.4 kilograms, whatever, 18 centimeters, plus or minus absolute error. Absolute error, remember, was half of the precision. And that's it. So you get 18 plus or minus 0.5 to get the limits of accuracy, which would be 17.5 to 18.5. Anyway, so let's have a look at some examples. So for 89.8 centimeters, the smallest unit is obviously the 0.8. And so you make that a 0.1. 0.1. 0.1 is the precision. And for 56.85 meters, remember we look at the last one, the precision is 0.01. We make this a 1, make this 0.01. And we make this a 0, we make this a 1, so it's just going to be 1 centimeter, the precision of this. And then we're going to half that precision, make a plus or minus, and just multiply with the actual measurement to get the limit of accuracy. So let's do something which isn't already written there. So for example, if it was 72.47 I don't know, meters, for example, then first thing we have to do, we have to find the precision of this measurement. The precision of this measurement is going to be 0.01 meter. Now we half this, and that's going to be 0.005 plus or minus. And the limits of accuracy of this measurement, limit of accuracy of this measurement is going to be 72.47, and it's going to be plus or minus 0.005. And that will give us the range of values. So on the lower end, it could be as small as, and we can certainly use a calculator here, 72.47 minus 0.005. And so this measurement could have been rounded up from 72.465. 72.465 meters, or all the way up until the upper bound, the highest it could have been rounded down from, which would be 72.47 plus 0.005, which would be 72.475. 72.475. And yeah, those are the range of values. Could be anywhere between there. And I guess you could use something like that. You don't have to worry about the notation, but that's okay. It's probably slightly wrong anyway. Key idea number 6. Now we move to percentage error. The percentage error is the absolute error expressed as a percentage of the given measurement. That is to say, percentage error equals to absolute error, which we have been determining over here. Absolute error is half the precision. So absolute error is half the precision, right? So just keep in mind, you gotta know what precision is. Once you know precision, you can do absolute error. To do absolute error, you need precision. Now, once you have absolute error, then you can do limits of accuracy, and you can do this one as well. Absolute error measurement. So for every definition, you kind of use it in the next definition, I guess. So percentage error is just absolute error over the measurement multiplied by 100. So what is the absolute error for the measurement 18 kilograms? And so in order to do that, first thing you need to do, determine the precision. Precision is 1 kilogram. 1 kilogram. Absolute error is half of that. And so it's going to be plus or minus half of 1 kilogram is half of 1 kilogram is half a kilogram. Plus or minus half a kilogram. And the absolute error as a percentage of the measurement, well, absolute error is plus or minus 0.5 kilogram over the measurement itself. Well, the measurement was 18 over here, 18 kilograms. And then we just multiplied by 100 because we want as a percentage. And that's pretty much it. And we can do this in a calculator. Where's my calculator? There it is. And so we can do 0.5 over 18 multiplied by 100, and then let's say 2.8 centimeters roughly is equal to roughly 2.8 centimeters. And now remember, there was a plus or minus, so it's going to be plus or minus 2.8 centimeters. And there you have it. That is the percentage error. So it's not hard per se. It's very robotic. Just try and understand what it all means, and that helps a lot in remembering it if you understand what it means. Remember the key idea number one: everything is an approximation. Every measurement is an approximation. They're approximation because they've been rounded off, and everything flows from that. What hasn't been rounded off from? That's the key idea. That's really all we've done. What has been rounded off from, and then without going, okay, I don't want to confuse you. Just you can rewatch the video, make sure you understand each one, and the main idea is that everything is an approximation because it has been rounded off, and we're just finding what has it been rounded off from. That's the main idea of this topic. So best of luck, and as always, you can ask me on Slack for more help if you need.